Hi, I hope you're doing great. Thank you so much for joining me this week. You know, nothing feels worse than getting a brand new Arduino board and then destroying it within the first 5 minutes of plugging the thing in. In this episode, we're going to talk about 5 mistakes you can make that can easily damage your Arduino board, with the whole intent that you can avoid them. We'll also talk about an Arduino Uno derivative board that protects against each of these mistakes. Everything has limits. If you try to drive a semi-trailer full of gold bars over some tiny country bridge, you could probably exceed the weight limit of the bridge, destroying the bridge and probably really screwing up the semi too. I mean, the gold bars would probably be fine, but I think you get the idea. You know, or if you're driving your car at 100 miles per hour and you try to stop it within 10 feet of a brick wall, well, you're probably going to get all smashed up. And it's not the car's fault. It has certain limits it has to be operated within. The Arduino is really no different. It has limits that it has to be operated within. In this video, we're going to discuss some of those limits and the results of exceeding them. If you know the limits, if you're equipped with that knowledge, then you'll be able to protect yourself from making mistakes and exceeding those limits. Now, all of the material that we're going to cover in this video is based on a really great article written by the manufacturers of Ruggedduino. So Ruggedduino is a US company that sells an Arduino Uno derivative board which protects against everything that we're going to be talking about in this video. It's kind of like the superhero of Arduino derivative boards. It's pretty much invincible. It prevents simple mistakes from damaging the board. Now, the article that Ruggedduino wrote is relatively in-depth on the technical aspects of why doing a certain thing can damage an Arduino, but I'm going to keep this video more focused for a beginner. So we're basically going to discuss mostly, hey, what not to do. And if you want to know more of the details of why not to do it, I'll make sure to link to the article in the description below. So the first thing we'll talk about is putting too much current through an Arduino I/O pin. So I/O stands for input-output, and what we're referring to are the digital pins 0 through 13 and the analog pins A0 through A5. So those are all the I/O pins on your Arduino. If we go to the Arduino Uno product page on the Arduino website and we come down to the specification summary, it says DC current per I/O pin, and it says it's 40 milliamps. Well, this is actually a limit of the microcontroller that the Arduino uses. It's a maximum current flow that is specified on that microcontroller's datasheet. So if we allow more than 40 milliamps of current to flow through any one of those I/O pins, then what you'll do is end up destroying the pin. You won't be able to use that pin anymore for inputting voltage or outputting voltage. It's going to be kaput. So there's essentially two ways that you could do this by accident. The first way is to connect an I/O pin that's been set as an output using the pin mode function, and then you write that output high using digital write, and then you accidentally connect that pin directly to one of the ground pins on the Arduino. So what happens is this creates an overcurrent condition on that pin. Now here's why. If we look at Ohm's law, we can calculate the current moving through the pin. You know, when the voltage is set as high on an Arduino pin, it delivers 5 volts. Now the internal resistance of an Arduino I/O pin is about 25 ohms. So that means that the current is around 0.2 amps or 200 milliamps, which is significantly over the 40 milliamp current for that pin that we just talked about. Without a current limiting resistor between the I/O pin and ground, we exceed the maximum allowable current flow and whammo, the pin's fried. So setting pins as outputs and writing them high is something we do all the time, you know, when we're using Arduino. So this is probably the most common mistake that could happen. When you've got, you know, a ground rail and a voltage rail on a breadboard and you're kind of prototyping around, this is something you definitely want to look out for, is not directly connecting one of those I/O pins to ground. Another way to create an overcurrent condition is if you have two I/O pins set as outputs. So again, pin mode set as output for two different I/O pins. And then you write one high, that'd be 5 volts, and then the other low, ground voltage, and then you connect them together. So you've essentially done the exact same thing as before by driving too much current through the pins. But now, instead of losing just one I/O pin, you've actually destroyed two. Here again, setting some pins high and some pins low are something you're going to do all the time using Arduino. So you'll definitely want to keep an eye out for making this mistake. So the Ruggedduino that we talked about before, it has built-in protection against this type of overcurrent condition. It's got a 30 milliamp resettable fuse in series with every single I/O pin. So far we've talked about overcurrent conditions, but there's also an overvoltage condition that can do damage. If we look at the data sheet of the microcontroller that the Arduino uses, there's a section that's called absolute maximum ratings. And on here we see this section where it says voltage on any pin except reset with respect to ground, and then it says it's negative 0.5 volts to VCC plus 0.5 volts. So for our purposes, we're going to say VCC is 5 volts. Anytime you exceed 5.5 volts on a pin, you can damage that pin, and you can do more than just damage the pin. So if you're working with some components that you're powering with a separate power source, and then you allow, let's say you're using like a 9-volt battery to power something else. If you allow that power, if you allow that 9 volts to be applied to one of the I/O pins, then you can damage that pin. And the actual damage is going to depend. It depends on how the fail occurs. In some cases, you're just going to lose the pin. And that's the good situation. But you could also screw up other components too, like the USB interface chip. So you definitely don't want to apply more than 5.5 volts to any of the I/O pins on the Arduino. So the Ruggedduino board is also able to protect against an overvoltage condition to any of the I/O pins. Like I said, it's kind of bulletproof. At some point in your adventures with Arduino, you're going to want to power your Arduino away from a computer, without the USB cable. And so, one common method is to say use a 9-volt battery. And you could either plug the 9-volt battery into the power jack, or you can actually plug the terminals directly in to the Arduino headers in the V-in and the ground. So the positive voltage of the battery, that positive terminal goes to V-in and the negative terminal goes to ground. But if you switch those pins, so instead of having the positive going to V-in, but instead you have the positive going to ground. So if you mistakenly do this, you're pretty much going to fry the microcontroller. And the 5-volt regulators on the Arduino board is also going to be destroyed. So you don't want to do that. And, as you probably guessed it, the Ruggedduino will actually protect against this reversing of voltages. And it will do that up to 30 volts, which is pretty impressive. Now, the final way that you can have a bad day with your Arduino that we're going to talk about today is if you apply greater than 5 volts to the 5-volt pin on the Arduino. Now you might be wondering, well, why would I ever put 5 volts on, greater than 5 volts on that 5-volt pin? That just doesn't make sense. And you're right, it doesn't make sense. You wouldn't normally do that. But this is really about mistakes that you can make. You can inadvertently do something. Maybe you were, trying to get one of the pins into ground to complete a circuit or something like that. That's when these mistakes can happen. So that's kind of what we're talking about here. This isn't something that you would necessarily easily do, but it's definitely something that can fry your Arduino board. So this just goes back to the limits of the microcontroller. Remember, we're not supposed to apply more than VCC plus 0.5 volts to any of the pins, and that includes that 5-volt pins. So not something you would normally do, not something you'd want to do, but something that could definitely happen and, make a bad day for you. And it's no surprise the Ruggedduino is designed to resist this. So it actually has a voltage cutoff circuit that makes sure that if you have the 5-volt connector pin, that actually gets disconnected if the voltage exceeds 5.5 volts. All right, so let's do a quick review of what not to do. Don't take an Arduino I/O pin, have it set to high, and then connect it directly to ground. Don't take an Arduino I/O pin, set to high, and connect it to another Arduino I/O pin set to low. Again, not a good idea. Don't apply a voltage exceeding 5.5 volts to any of the I/O pins. It's going to destroy those pins. If you're going to apply power to the Arduino through the V-in header connectors, make sure not to reverse the polarity of the V-in ground power connections. Do not apply greater than 5 volts to the 5-volt connector pin on the Arduino. All right, well, hey, I hope this video was helpful. I hope that you can avoid all these mistakes. I really appreciate you taking the time to watch this week. I do have, if you're interested in learning about Arduino, our open source hardware group website, you can go there and sign up for a free course to learn about Arduino. It really kind of walks you step by step through getting familiar with the hardware and the software. We also offer a premium course that really takes you from not knowing anything about electronics or programming, walks you through, and really sets you up so you can do a lot of neat stuff. Well, thanks again for listening to the show. Next time we meet, we'll actually be talking about 5 more ways we can destroy an Arduino, and that should be next week. So I look forward to seeing you then. Have a great day. Bye.